Hello and welcome back. We are going to do a lecture today discussing rational exponents, which is also an extension of what we introduced last time, which is power over root. Very simple concept, very powerful for us to use. So let's dive in and see what it looks like. So if I have from the exponential some base of a, if I were to have an exponent that looked like a fraction, something like 1 over n, for example, the denominator value here is what we call the root index. And so converting from the exponential form that you see here into the radical form that you see here, I would have the nth root of a. Again, that n value comes from the denominator. A is raised to whatever power I have left. In this case, it was 1. So it's a to the first, which is just a. It's the same exact thing. So that being said, let's see how this helps us as we solve problems. Let's say I have the first example, which is 64 to the 1/3 power. And I get a simple instruction like simplify. That's it. In this case, what I would do is I would convert from exponential into a radical form. So I would have my base, which is 64. I know it's going to become a radicand. My root index is 3. It's this denominator value. So that's a third root of 64. And it is raised to the first power. Well, 64 raised to the first is 64. So I'm not going to write the first power. What is the cubic root of 64? We've solved these before. We know that to be 4. And that is it. That's how you use your rational exponents. Let's try another one. Very easy one. 100 to the 1/2 power. Converting this would be the square root of 100. This is a root index of 2, so I'm not going to write it. It's already implied. This is a power of 1, so I'm not going to write it. It's already implied. So what is the square root of 100? 10. That's it. What about negative 256 to the 1/4 power? Ooh, negative. What do we do? Well, fortunately for us, what is the base? Just the 256. This negative is separate. It's out of here. So I'm going to write that as a negative 1 times my 256 to the 1/4, just so I can see that. Now, I'm going to convert this part right here, the 256 to the 1/4. So I have a negative 1 times, don't drop this off. This is the 4th root of 256. Now, what is the 4th root of 256? 4. So this is a negative 4 as an end result. Now, how is that different than if I had parentheses? So negative 256 to the 1/4 power. Well, now my entire base is this negative 256. And when I convert it, I get the 4th root of a negative 256. But wait a minute. I have an even root index of an odd radicand. Ugh. That doesn't happen, so it does not exist. Very good. Now, that being said, what if I had an odd root index? So something like negative 32 in parentheses to the 1/5 power. Well, as I convert it, I see that I have an odd root index, and so I can have a negative for my radicand with an odd root index. That is completely feasible. The 5th root of 32 we knew was 2. The negative here makes that a negative 2, because you could expand it. It'd be negative 2 times negative 2, so on and so forth. All right, let's try a fraction. Let's say I had 1/8 to the 1/3 power. Ooh, that's interesting. Technically, converted, it looks like the cubic root of 1/8. But you could technically do those separately, right? So let's do that. So that would be 1 over 2, because the cubic root of 1 is 1. The cubic root of 8 is 2, so that is 1/2 as an end result. Now, extending this same line of thought, all of our powers, if you were to look at this structure, all of those numerators on the exponents are currently 1. But what if my power, my numerator value, was not 1? What if I had 36 to the 3/2 power, to a rational exponent of 3/2? Well, I'm going to follow the same process for converting, but check this out. My root index is 2, so I have the square root. The 2 is implied. My radicand value is 36, right? And then I have this cubic value. So I have this 3 from my power as my power for my base, for my radicand. Now, you might be looking at this and saying, oh man, 36 to the 3rd power, why would I want to do that? You don't. You don't want to do that at all. In fact, here's the cool thing about power over root. You can do this exponent after you take the square root, if it's easier to do. That is perfectly okay. So that's exactly what we're going to do. We're going to take this cubic root, this cube exponent, and we're going to apply it after we take the square root. So square root of 36 is 6. This power of 3 is still there. 6 to the 3rd is going to be 216. And there you go. Much easier to do than if you were to cube 36 and then try to figure out 216 from that. Let's try another one. Pretty awesome concept once you start getting the hang of it. It does take practice. What if I had 125 to the 2/3 exponent? Start with your conversion. So that's the cubic root of 125 squared. I'm going to do that square afterwards. So the cubic root of 125 is 5. Squared is 25. Pretty easy to work with, right? Let's try this next one. I have -4 to the 5/2 power. -4 to the 5/2 power. Be very careful about what your base is. That negative is separate, so I'm going to write it outside. I have a square root, so it's a negative square root of 4 to the 5th power. Well, square root of 4 is 2, so it's a -2 to the 5th power. Keep in mind, only this 2 is raised to the 5th, okay? So 2 to the 5th is 32, excuse me. That negative then applies, so it's -32. Excuse me on that. All right, let's try another, and let's get some board space. This one, there we go. Got to make sure I'm not losing my place. So I got -27 to the 2/3 exponent. I am going to start by converting. So that's going to be a cubic root of -27 squared. Now, I'm going to do the cubic root first, but make sure you keep parentheses because you have a negative in that base. So cubic root of -27 is -3, and I'm still squaring. -3 squared is +9. Okay, let's look at another one. I got a -100 in parentheses to the 3/2 power. Get this formatted. I have the square root of a -100 cubed. Ooh, wait a moment. I can't take an even root index of a negative radicand. Yikes. How do I know that? Well, this -100 wouldn't be cleared out if I were to multiply this by itself 3 times. It would still be negative because that's negative times negative is positive times another negative is negative. So my radicand would still be negative here. Does not work. world implodes. This is a does not exist. Okay. Now, the power over root concept, which is what we have been working with so far, is super, super easy. But I want to stress that all of your exponent rules still apply. All of them. So this is where you probably want to have your exponent rules handy because we're about to jump into utilizing those exponent rules. For example, if you were to have a negative exponent on something like 16 to the negative 3/4 power, the first thing that I would personally do is I would take care of that negative exponent. I would invert this so that it is 1 over 16 to the 3/4 power. Now you might be saying, well, wait a minute, why do you have it like that? Technically, this 16 is over 1, isn't it? So my base is 16 over 1. I inverted my base. I reciprocated it, taking care of that negative exponent, making it positive. And that gave me 1 over 16 here. So that's perfectly fine. At this point, I would do my conversion. So I have the 4th root of 1/16 to the 3rd. 4th root of 1 is 1. That's easy. 4th root of 16 is 2. This is still raised to the 3rd power. Cubic root of 1 is 1. Cubic root of 2 is 8. So I get 1/8 as my result. Let's say I have 25 to the negative 3/2 power. Excuse me. So if I have 25 to the negative 3/2 power, I'm going to do the same thing. I'm going to invert it. It's 1 over 25 in parentheses. That's my whole base. To the positive 3/2 power. This is the square root of 1/25 cubed. That is 1/5 to the 3rd, which is 1 over 125. So again, taking it step by step, you're simply going through, you're taking care of that negative exponent first, and then you're converting from a rational exponent to the radical form. Simplify that radicand. I highly suggest doing that first every time, whenever possible. That gives you 1/5 to the 3rd power. Simplify this, and you get your 1 over 125. Now I'm going to show you another one here, just because this is something that you might see in your homework, on a test, quiz, whatever. Because never do you just have problems that are super easy, right? Sometimes you get problems that are like this. Fractions. Fractions are friends. That's okay. So here's what we're going to do. I have 8 over 27. It's all raised as a base to the negative 2/3 power. So I can say that I have 27 over 8. I reciprocated to the positive 2/3 power. Convert it. I have the cubic root of 27/8 squared. Now, you might be looking at this and saying, oh, boy, that's a big fraction, right? Well, think of it like this. It's technically like saying I have the cubic root of 27 over the cubic root of 8, right? The whole thing is still squared because I got that square out there. So it's basically saying take each individual piece and look at it. Cubic root of 27 is 3. Cubic root of 8 is 2. It's squared still. So that gives you 9 over 4. So don't make it overly complicated. Just go through, take it step by step. And then if you see a fraction like this, you can split it up. That's okay. You could also combine it if it makes your life easier. I split mine up in this case because it was easier to say cubic root of 27 is 3, cubic root of 8 is 2. This whole thing is still squared, and that's where I get my 9/4. Perfectly fine either way. Now, let's talk about an example here. I'm going to get some board space because I want it to be very, very clear, and I don't want it to get confused with anything else I have written, because this is a common misconception. Let's say I have 16 to the negative 1/4, and I have negative 16 to the 1/4. Now, in these two problems, they look very, very similar, but the placement of that negative has a very impactful meaning. Here's why. Here, I'm talking about a negative exponent. The negative exponent is telling me that I must reciprocate my base. So I must reciprocate my base. That then makes this a positive exponent, and I follow through with my conversion. I get 4th root of 1/16, which is 1/2. This negative outside of my base is completely separate to begin with, so leave it alone. This is a negative, and then I can go straight into converting, because this is already a positive exponent, so that is a negative 4th root of 16, which is a negative 2 as an end result. So don't get confused on where these negatives are, and make sure you have a very clear understanding of how that negative applies to that problem. Okay. Now, I did say that we are going to utilize all those exponent rules. Just so that you have them handy, there are exponent rules already in your notes in this big gray box. So you do want to make sure you look at those exponent rules. Now, that being said, let's say I have 2 to the 1/2 times 2 to the 1/4. And I am given a simple instruction which says, simplify, write all answers using positive exponents. So I know my end result here should end with an exponent value, and it should be positive. So go back to your exponent rules. Looking at this, do I have the same base? Yes. That means I can apply that product rule, meaning I add my exponents together. So I have the base of 2, and I'm adding my exponents of 1/2 and 1/4. How do you add fractions? Got to have common denominators. Currently you don't. So 1/2 is easily converted to 2 over 4, excuse me. That's 2 over 4 plus 1/4. And this would be 2 to the 3/4 power. And again, it says, write all answers using positive exponents. Is your answer in a positive exponent? Yes, it is. Leave it alone. Let's try another one. Let's say I have 5 to the 2/3 over 5 to the 7/3. I have the same base, so I can apply quotient rule here. That's going to be 5 to the 2/3 minus 7/3, which means this is 5 to the negative 5/3. I currently have a negative exponent, so I want to invert my base. So this would be 1 over 5 to the 5/3. And that is perfectly fine. All right, let's get a little more complicated. Let's put some variables in there. So I have x to the 1/2, y to the 2/3. This is all a base raised to the 4th power. And I am dividing everything by y. And you might be asking yourself why, and that's because it's a variable. Sorry, crude humor. I'll be here all week, at least virtually, in a video, talking to myself in an empty classroom. It's okay. Okay, now that we've got the anxiety out of the way, let's go back to the problem. We have x to the 1/2, y to the 2/3, all of that raised to the 4th power. What? Now, think about your exponent rules. You can use your product to a power rule. So we're going to do that. We're going to distribute this 4 to each one of our exponents that you see throughout the problem. So this is x, 1/2 of 4 is x to the 2nd. Y, this is 2/3 to the 4th. So that's going to be y to the 8/3. Because that's like a 4 over 1. Think about how you multiply your exponents. You're still over y. Now, I have the same base here. The y here has an exponent of 1, so that's like saying I have an exponent of 3 over 3, technically. Why did I choose 3? Well, my denominator value of this exponent is 3, so I'm making it a little easier on myself. So I have x squared, y to the 8/3 minus 3/3. So that 3/3 again is 1, because that's what it was originally. This then gives me x squared, y to the 5/3 power. Did you write your answer using positive exponents? Yes. There you go, you're done. All right, let's try this next one. This next one is beautiful. So I have x to the 4th, y to the negative 6th, all divided by x to the negative 2nd, y to the 1/3, all of that raised to the negative 2/3 power. And you might be wondering, why are you so cruel, Dr. Martin? It's easy, because I can be. So here's what we have. I have x to the 4th, y to the negative 6th, over x to the negative 2nd, y to the 1/3, all of that raised to another exponent. What do I do first? Well, there's a couple different approaches. You could try simplifying inside of your parentheses first, and then apply that exponent outside. Or you can apply the exponent from outside now, raising essentially your quotient to a product, and then you're able to then simplify. It's really up to you. I personally am going to simplify inside before applying this. That's just me. So I have x to the 4 minus negative 2 using my quotient rule here, y to the negative 6 minus 1/3 using my quotient rule here. All of that is still raised to the negative 2/3. This one is nice. 4 minus negative 2, that's 6. This one's not so nice. I have to do a little bit of work because that 6 is currently over 1, but I need it over 3. So that makes it a negative 18/3 minus 1/3. All of this is still raised to that negative 2/3 outside. Combining my terms here, I have x to the 6th, y to the negative 19/3. The 6 right there. And this is all still raised to the negative 2/3. At this point, I'm going to go ahead and distribute my negative 2/3 to each of my exponents. And so that's going to give me x to the, notice I can divide 3 into 6. I'm not going to. I'm going to show this whole process, but you could simplify if you're one of those people looking at simplifying as you go. So this would be x to the negative 12/3, y to the positive 38/9. So I'm multiplying my exponents, and that's giving me a negative 12/3 here and a positive 38/9 here. Now I see that this is a negative exponent, so I am going to go ahead and invert it, and I'm also going to simplify 12 divide 3 at the same time. So I have y to the 38/9, there we go, divided by x to the positive 4th. So again, I saw this as a negative exponent, so I inverted that term, and I have 12 divided 3, which is my 4. Was it that hard? Not really. You just got to take it step by step and work your way through the process. So other than that, this is the end for section 10.2. I will continue into another section in just a few moments.